Alright, this video is for Honors Algebra 2. It is 6-5, operations with radical expressions. The first slide for this video is going to be called the product property of radicals. What this slide basically does, it defines using factor trees to break up radicals. Just does it in a little bit more of a technical fashion. So that if you look at it kind of in reverse, honestly, if you think about this, you know, had the square root of 16 can break up as 2 and 8, or you can go the other way with it. The same thing over here, you know, cube root of 27 goes cube root of 3, cube root of 9. It's basically letting you split radicals up into 2 and put them together as 1. So obviously, if you're going to multiply these radicals together, you would multiply the insides, make it 16, multiply these insides, make it 27. It also allows you to go backwards too, which is where your factor trees come from, and that's what we're going to do first. So number one here is starting with a very basic example, the square root of 32 x to the 8th. So first off, what you want to do is factor tree your 32. So if you want to factor tree 32, you know, you do that as you have been for a long time. So 16 and 2, 16 goes 4 and 4. So you have a pair of 4s that can come out of the radical and a 2 that stays in. So it used to be, you know, just 4 square root 2, and that'd be the end of it. But now you have this x to the 8th to deal with. And so now you have to break him up also, and you're still going to break him up in a sense that you're going to look for multiple, you're going to look for pairs of factors of x to the 8th. Now if you recall with your exponent rules, there are a lot of different paths to get to x to the 8th. You can multiply x and x to the 7th. You can multiply x squared and x to the 6th, x to the 3rd, x to the 5th, because you're adding up the exponents. The ones you want are the ones that's going to pair up, and so that's going to be splitting it up as x to the 4th and x to the 4th. Because if you multiply those together, you add up the exponents. So there's your partnership of your x's. And so now you rewrite. Your circles come out. So 4 x to the 4th. Your box stays in, square root of 2. If you noticed from the last video, the last lesson 6.4, all of those worked out perfect. Where the changes today is that they don't all work out perfectly. Today you will have radicals left inside. You still have to check. Whenever it's just simplifying like this one here, you still have to check for your absolute values, but you have an even index, even power, and then even on the answer, so you're good without absolute values in this case. And now where this changes, the reason why you always pick pairs was because you need a square root. Well, once we change that, you change what you need. You go accordingly to your index of how many you need in your partnership. So everybody's first move, so we have number 2 here. Sorry, I'm getting ahead of myself a little bit. You had the 4th root of 16, a to the 24th, and b to the 13th. So everybody's first move with 16 has always been, you know, just go 4 and 4 because it's a perfect square and you're done. But now you need 4th powers, so you need 4. You don't need 2 in a group with the 4th root. You need 4 in a group. Luckily for us, we can keep going with 4 because each 4 breaks up into 2 and 2. Now maybe you know that the 4th root of 16 is 2. That's fine, good for you. But you're not always going to have these being perfect numbers, perfect roots all the time. Sometimes your numbers are going to be ugly. You're going to have leftover factors that you have to find and put back into your problem. So I want you to know how to do the factor trees. Make sure you look at your index. Index is the most important number in these problems, guys, all the way through. This number right here is the most important number in any problem you do with a radical. So make sure you look at that first thing so that way you know how many you need in a group. Now, for the variables, so I don't want to get it kind of, you know, clumped together there. So I'm going to write these out here. So a to the 24th and then b to the 13th. Couple different ways you could do about it. You know, like I said, there's multiple ways to get to 24. You can do 2 factor trees at once, so a to the 12th, a to the 12th, and then a to the 12th they go a to the 6th, a to the 6th, a to the 6th, and a to the 6th. Obviously, you don't want to split it up into writing it 24 A's, because then you have to group those up into 4, and you're going to be circling them a long time. So kind of know where you need to go. Once again, if you figured out the trick, you can kind of divide your index, or you can divide your power by your index, and that's going to be what the exponent is. So obviously this one's going to end up being 6. There we go. And then, but sometimes also you have to make sure and see if it works out evenly. So the b to the 13th doesn't. Whenever that's the case, my first factor tree is always to make it even. So b to the 12th and then b. Because remember, you have to add the exponents up here to go back to here. So I always add those together. And now I can break up b to the 12th into, b to the 6th, b to the 6th, and then b to the 6th as they go b cubed, b cubed, b cubed, b cubed, and then there's your 4b cubes. In this case, you're left over this one lone factor of b. So now you take everything that's circled up. Remember, you're looking for 4s. Part 4s in your group, so you have one group of 4s with your 2, or one group of 2s, so they come out as 1. You have one group of a to the 6th. You have a group of b cubes. Okay, once again noticing even index, even power on the inside. That's not even power, hold on. 13 is an odd number, so you don't need absolute value since you go even to odd. So 2a to the 6th, b to the cube. The only thing you can't forget about is that you have that leftover factor of b. And the other thing you can't forget about, and this is new to this lesson because this is the first time we've had leftovers, is your index. Okay, so right there, the 4. Make sure the index in your answer gets put there. If it's not there, I take points off. Because it's a signal. It's telling me you know what type of root you have. And you have to know which types of roots you got, because otherwise, you're going to have, you're going to go from fourth roots to square roots, from cube roots to square roots, and they're totally different things. So your indexes have to be in your answers. Now, much like everything else with these problems, we have a little more difficult problems here. I'm not going to say a whole lot about this slide because it kind of is a little bit confusing. So if you need to write stuff down from this slide, if you want to write stuff down, what I recommend you writing down is kind of right here, the examples here. I really wouldn't worry about the words so much. You guys kind of know that, you can, just like multiplication, you can also split them up. But do write this box here, and I'll explain it why here in a little bit. I'm going to pause my video, you can pause yours, and whatever you feel like you need from this slide, go ahead and copy down. But I'm going to pause for just a second and let you write it. Okay, so if you remember from like when you first did rationals, you have an example where you need to rationalize your denominator, and that's what's in this box right here, a simple one, a very simple one. So you had 2 over the square root of 3, multiply top and bottom by rad 3, and you get 2 rad 3 over 3. Alright, so at this point, making this quick leap in 2 steps shouldn't be a problem for anybody. What we're going to do next, or here soon, is we're going to change the powers on you. We're going to make them cube roots, fifth roots, what have you. And that's where these get a little complicated. So I want you to remember what you're trying to do. You're trying to rationalize your denominator. Keep this in mind as we go forward. Another slide you can kind of summarize if you feel the need are your simplifying radical expression rules. A radical expression is simplified form when the following conditions are met. Number 1, the index is as small as possible. That one kind of doesn't really come into play this lesson. It definitely does on the next video. So keep that in mind for 6.6. The second bullet there, the radicand contains no factors other than 1 that are nth powers of an integer or polynomial. That's just fancy talk for you can't have factors left in your factor trees. So if you factor tree everything and you do that correctly, that one shouldn't be an issue to you. The 2 we're going to mainly focus on next are the bottom 2 here. Your radicand contains no fractions, so you can't have a fraction inside your radical, and you have no radicals in your denominator. And that's where the contradiction comes of a certain problem. So if you haven't finished simplifying it, pause here, but I'm going to move on. So number 3, you have x to the 6th over y to the 7th as a square root. Now, if you follow your rules, it says, no radicand contains no fractions. All right, you have a fix for that because you also have a rule from the slide prior that says you can split it up. So you can have the square root of x to the 6th over the square root of y to the 7th. Now, where your contradiction comes in is the fact that now you have a radical in your denominator. So you're kind of at this point you're kind of just running in circles. So you haven't really fixed anything yet. So now you have to go into rationalizing your denominator. That way you can get rid of the radical that's in the denominator. That's the whole point of rationalizing a denominator, is to get rid of the radical down there. So what you're going to look to do is multiply by such a square root that will allow you to take a perfect square of your denominator. In this case, it would be y. Why? Simple. It makes the square root of y to the 7th become the square root of y to the 8th. I'm going to go ahead on my denominator just a little bit, which will give you y to the 4th. Okay, so that's why you multiply it by y. If you do by y to the 7th, you'll get y to the 14th, but then you'll also have cancellations to do up in your numerator. So I always look at what will let me take what next exponent of y, what next power of y will let me take whatever radical this is. In this case, it's a square root, so I know I can take the square root of even powers. So I'm like, all right, so here's 7, so I need to get it to 8. How am I going to get it to 8? By multiplying it by the square root of y. Now that's all for your denominator, because that's very much how your denominator dictates your problem. So that has to be without a square root. Upstairs does not. All right, so we can combine these two, make it the square root of x to the 6th y, and then you go ahead and simplify the square root of x to the 6th, make it x to the 3rd, and then you have that square root of y left over. Once you get into powers like this, like if you notice, technically speaking, you have even power here, or an even index, even power on 6, odd power on 3. Once you get past simple simplifications and you get into rationalizing and multiplying radicals and all that other stuff that we're going to do, your absolute value rules get very, very messy as far as when it is proper and when it is not. So I only worry about it when you're simplifying a single radical. So if you're doing anything other than simplifying a single radical, I don't particularly care to see absolute value bars anywhere. Like I said in the last video, I'll be very specific as to when I want to see them. Okay, so now obviously you can see we've got numbers in this time, we've got 4th power this time. Kind of changes your problem. It doesn't change your first step though. Your first step's always going to be split it up into 2. So you have the 4th root of 6 all over the 4th root of 5x. And so like I said with the last one, we're going to look at multiplying this by top and bottom. Remember, these have to be the same. By something that's going to give us, something that we're able to take the 4th root of. And here's how I want you to think about this. You know you need a fourth root, and we know fourth roots cancel fourth powers. So here we have a factor of 5. So I have 1, I need 4. So if I can just introduce 3 more factors of 5. All right, now, I believe that as 5 cubed. I don't write that as 125, and I'll show you in a minute why. Same with your x. You have 1 factor of x. So now you have, whoops, getting ahead of myself again. So now you have x cubed. And then you do that at top and bottom. Okay, and once again with this problem, I'm going to kind of work my denominator out ahead of time just to show you why I do the crazy methods that I do. You have a fourth root below. Now, if you use your exponent rules, and this is where the minds kind of get lost because your instinct is to take this cube root and multiply it. Apply it as if it were a variable. You have 1 5 here, you have 3 5s over here. That's 4 5s total. So 5 to the 4th. Notice how this fourth root will cancel this fourth power and you're going to be left with just 5. Alright, same way with your x's. You have 1x here, you have 3 over here. So you're going to have 4 down below. You could care less what 5 to the 4th is. You really could. Because if you read it like this, you know it's going to cancel out to be just 5 and x. That's what you're looking for. You're looking to add in with your rationalized step right here. I always do this in red. Always. Every year I've done this in red ink. Because this is the step that matters. This is the part that dictates your problem. This is where you need to make sure that this power plus this power equals your index here. Because it allows you to take it down here and get rid of it and leave it as just 5x. Your denominator will dictate your problem. Your numerator is what it is. Alright, so we're going to rewrite that now. So the fourth root of 6 times 5 cubed x cubed. If there were any factor trees you could pull out of this, you would. But 6 factors out to be 2 and 3. Then you have 3 more 5s, so you need 4, you don't have any, so go ahead and multiply all that together. So you have the fourth root of 750 x cubed. And that's your answer. Okay, I'm going to go ahead and let you guys try these two. Be careful on number 6. You may not have to do everything you think you do. That's the only hint I'm going to give you. Be careful on 6, so go ahead. Okay, so the answer for number 5, pretty simple one. You have to multiply by square root of b top and bottom. It gives you the square root of a to the 9th b over the square root of b to the 6th. Simplify the top, gives you a to the 4th times the square root of ab. The bottom gives you b cubed. So a to the 4th square root of ab over b cubed. Number 6, check your work here. Make sure, I'm willing to bet I have less work than you guys. Rewrite it at top. Alright, so probably if you did everything I taught you, which is fine, your red step is probably 5th root of 4 to the 4th y to the 4th, but I'm going to ask you this question. 4 has how many 2's in it? And the answer to that is 2, right? Because you can factor tree 4 out to be 2 and 2. So I'm going to rewrite 4 as 2 squared. So there's 2 of my 2's. So I added in 3 more to give me 5 total. So that's a nice little trick if you ever see that. And I guarantee you there will be one like that on your test. It's a whole new way of thinking about how you write your numbers in this problem. Up top you have 2 cubed y to the 4th, you get 24 y to the 4th. Now, if you didn't catch that, your answer here hopefully it'll be the same. Don't get me wrong. You should have 5th root of 24 y to the 4th over 2y as your final. Your inside radicand number is probably bigger, and chances are it can probably be simplified. And then chances are it'll cancel with the 4 that you have down here. So check your inside of the radical here if that's what you got. Simplify it down, and then you'll be good. We have about 4 problems to go yet. and we're going to kind of, I'm not going to try to pick the pace up, but we're going to kind of, move somewhat quickly. I'm going to show you this problem here, and this one's probably the hardest one that we have left. You have 5 times the cube root of 12ab to the 4th times 3 times the cube root of 18a squared b squared. Some teachers, they'll tell you multiply everything together and then simplify that whole mess. I don't fully believe in that. I don't fully like it. Here's what I'm going to tell you to do. We know we need to multiply the outsides. So 5 times 3. It's going to give you 15. Okay? So let me move that just a little bit more out of the way. There we go. Now what I'm going to tell you to do, I'm going to tell you to factor tree everything right now. So 12 goes 4 and 3. 4 goes 2 and 2. 18 goes 6 and 3. 6 goes 2 and 3. And now, since I can do this, I have colorful things. I'm going to look for, my indexes are 3, so I need triplets. So here's a 2, here's a 2, here's a 2. So they're all going to come out as 1, 2. Same thing. Here's a 3, here's a 3, here's a 3. They're all going to come out as 1, 3. So instead of making it, 12 times 18, which is, 216, okay, it's 216 is a nice cube number, you should know. But sometimes that won't be the case, so that's why I like to show you this example with it broke up like this. They're going to put these two numbers into factors and just break it down anyhow. So, I can make it be 216, and then my first factor tree of that is 12 and 18. And then it just goes from here. So there's really no point in multiplying them together. If you notice, you have an A here and 2 A's here, so that's 1A that comes out. And then you have 6 B's total, so that'd be 2 B's. Okay, so you have 15 times 2 times 3 times AB squared, so that gives you an answer of 90 AB squared. Alright, so like I said, next few examples are somewhat simpler, stuff we've done before, stuff you've seen before, so we're going to kind of fly through it. So, to add or subtract radicals, they still have to be, same index, same radicand, they have to be like, okay, that hasn't changed at all. Right now it looks like you can't do anything, but your friends, the factor trees, they can always help you out. So you look at 98, split 98 up, 49 and 2, and 9 goes 7, 7, so square root of 98 goes 7, square root of 2, minus 32 goes 16 and 2, 16 goes 4 and 4. The 4's come out multiplied by the 2 in front, so that gives you minus your 8 square root of 2. So just because they're not like radicals right away doesn't mean they won't end up being after you simplify. Then 7 minus 8 gives you the negative 1. Radicals don't change. So negative 1 square root of 2, or my preferred answer, negative rad 2. Another quick example with these would be whenever you had to FOIL. Once again, binomials touching, you're going to FOIL them out. So multiply your outsides together, multiply your insides together. So your first times your first, so 4 times 3 gives you 12. 3 times 2 gives you square root of 6. Your outsides, so minus 24 square root of 3. Your insides will give you 15 square root of 4, and then your last be minus 30 square root of 2. So you FOIL them out, you go through, you look at them all, and then you notice something about that green term right there. Hopefully you can see that it's going to end up being 12 square root of 6 minus 24 square root of 3. The square root of 4 is 2. So 15 times 2 gives you 30. Minus 30 square root of 2. Now, just like normal, if there were any like terms in there, you would combine those after that, but there aren't. You have the radical of 6, 3, and 2, so there's no like terms to go. So then from there, you got your last example. It kind of goes back to the conjugate example from chapter 4. Just like getting rid of i's, you're going to multiply by the conjugate here, so square root of 5. You have a minus 1, so you need the plus 1. After that, it's just straight normal distributing and foiling and stuff like that. So that's why I'm kind of going a little quickly. So 2 square root of 5 plus 2 over 5 times square root of 5 times square root of 5 gives you square root of 25, or just 5. You know, if you remember from conjugate rules, your inside multiplications, they better cancel. So negative 1 times positive 1 gives you negative 1. So then what to be careful of with this is you have 2 square root of 5 plus 2 all over 4. And if you notice, there's a factor of 2 which you can cancel out from all three of those. So you have just a square root of 5 plus 1 all over 2. Okay, so very important to kind of take that slow, or make sure at the end there you can reduce those if they can. Like I said, if they can't, then that's all you get. Once again, end of this one here. I know it's kind of been a couple of longer videos. There's a lot to talk about with these rules, a lot of writing with these. The concepts, though, aren't terribly tough with these last two. So then give you a little bit of assignment. You got 1 through 17 odd on page 419, along with number 51.